Okay, class, welcome to the handout for section 2.4 on quadrilaterals. Quadrilateral is a shape that has four sides. So the quadri means four, and quad means four, and lateral means side. So we're going to go ahead and take a look at some example quadrilaterals. So here's an array of four different four-sided figures, and we're going to do a sort, just like we do with the triangles. We need to think of categories and based off of characteristics that we determine. Okay, so go ahead and pause the video for a little bit and investigate the sample quadrilaterals. Look at characteristics they have in common with each other, and go ahead and write down your categories and your characteristics that they are, and then put the letter of the quadrilateral in that category. Go ahead and pause the video now. Okay, so now that you've tried to sort these with characteristics that you determine, you have many figures that look like they're similar. For example, we have, upon my investigation here, we have A, B, E, and I. All of them have four right angles. Okay, they're all like all of these have four right angles. Okay, so we can go ahead and do a category of four right angles. But some of these in between A, B, E, and I have same length sides. Looks like these are the same length over here. And B and I have same length sides, so that makes them different than A and E, which don't. But they have, that's the side there, but these two are the same, and then these two are the same. Okay, so use marks to help us determine. So one mark, everything that has a side with one mark will be the same length, and everything that has a side with two marks will also be the same length. So four right angles is like one part of the characteristic, but we have to have four right angles in two of these categories. So we have four right angles . Oops, and let's do, yeah, so we'll do four right angles and four equal sides. That's that category. That was with B and I. Okay, so four right angles / four equal sides. And there's some that just have four right angles. And let's go ahead and put that was A and E. All right, let's look for some other characteristics that are the same between some of the rest of them. Let's see, C. Take a look at C, J, F, and L all seem kind of similar. Okay, they all seem similar, that they're kind of slanted. Okay. Let's see, slanted. Okay, but there is something also curious about them, that since they are slanted, but these ones have same length sides as well. So this one right here and this one right here, these are all the same length, even though they are slanted. And C and L looks like it's like that as well. That they have the same length sides here. Okay, so C and L have same length sides, four equal sides. They're kind of tilted here. Four equal sides, tilted. So that's C and L. And F and J are also kind of just tilted, if you will. Okay, so we got those ones done. And they also have kind of the same like sides here too. This one's the same as that one, but these ones are the same as this one. Okay, so F and J, and then we have, let's take a look at like H and N look like they're something. H and N here. These look like kites to me, like the ones that you fly. So what do we have? What are those characteristics? Well, let's take a look at their sides. This side looks to be the same as that one, and that one looks to be the same as that one. Okay, same thing with this one. And those, for lack of a better word, we'll call them kites, like the ones that you fly. So H and N. Okay. Part D and G and K, those kind of look like the same, but G is different because it's kind of tilted here. D and K look like they're not tilted. Like these segments on the top and bottom are parallel. Okay, so parallel segments are used with marks, like a little arrow, part of an arrow. Those are parallel, and those are parallel. So they have one set of parallel sides. Okay, so that's that category. That's D and K. Okay, now category 7 is what's left. And so what do we have left? We have G and M. Now they don't look like they have same length sides or parallel or anything like that. Right angles. So these are going to be kind of the odd ones out. We're going to call them odds. G and M. Okay, so we got kind of our categories set, and we can now have similar characteristics. Okay. So what we have for the next page, this down here, is a hierarchy. Okay. Hierarchies are great in math because they're like kind of visual organizers, kind of graphic organizers. You can do a little web with these shapes. Okay, so all of our quadrilaterals are listed there, and this is where we kind of learned what the names of these things are. So I'm going to zoom in here. And this first one is those odd shapes, and this actually the generic quadrilateral. There's nothing special about it, just any four-sided figure. No parallel segments, no parallel sides, no same length sides or anything like that. So we're going to go to our thing here, and we're going to say that this is a quadrilateral. Okay, general quadrilateral. The second line by the figure is for the definition. Four-sided figure. Okay, so four-sided geometric figure. The next one here, as we go down the level of the hierarchy, so here's the top level right here. Here's the next level. The next level all the shapes are quadrilaterals, but with one additional characteristic, something special about them that makes them different than the generic quadrilateral. This first one is called a trapezoid. And a trapezoid is a quadrilateral with one set of parallel lines, segments, sides. So I always get that confused. Parallel sides. Okay? That's a trapezoid. Here's level 1. Level 2. Okay, by those rows. Okay, so that's a trapezoid. And when you have a definition, let's go ahead and be more formal with the quadrilateral. You have a definition where you want to separate our figure from everything. So a quadrilateral is a 2D geometric figure with 4 sides. Okay, so we separate by definition, we separate the figure from the shape of the category of all geometric figures. Okay, so we use 2-dimensional, we use geometric, we use 4 sides. A trapezoid, we need to set that apart from all the other quadrilaterals. So we say it's a quadrilateral with 1 set of parallel sides. That's its distinguishing characteristic, just one, not any more. The next one is a parallelogram. And a parallelogram is a quadrilateral with 2 sets of parallel sides. That's this distinguishing characteristic. Okay, 2 sets of parallel sides. What we have for the next figure is, even though it looks like a kite, that's the official geometric name for it too as well. So it's a kite. A kite is a quadrilateral with 2 sets of consecutive equal sides. Okay, I use the word consecutive because they're in a row. Okay, so here's one set of equal sides right here as we go around the clockwise. Here's the other set of equal sides here. Okay, that's its distinguishing feature. Parallelograms have 2 sets of equal sides as well, but they're not in a row. They're like opposite each other, like this one and this one. Okay, but we've chosen to define our parallelogram by parallel sides here. So 2 sets of parallel sides. So there's 1 set on the top and bottom, and then the left and right are also parallel. So we're going to mark them with 2 little arrow marks. Okay. The trapezoid again had only 1 set. So 1 set of arrow marks. Excellent. Now going on to level number 3. Level number 3 is they have lines connecting to the level number 2, and each of those shapes in level number 3 take on all of the characteristics of the top of the upper level, the level above. Okay, so we can say that a rectangle is coming off of the parallelogram. Okay, so this is the rectangle, and the rectangle has all the characteristics of a parallelogram and 1 other set of new different characteristics. So rectangle is a parallelogram with 4 right angles. Okay, it has the same thing, like the sides are parallel, there's the same length opposite each other, but the distinguishing characteristic is that all of these angles are right. Okay, the other level 3 is this figure here, which is a rhombus. And I need to make a distinction between a rhombus and a diamond. A lot of people say diamond, but it's not like mathematically official. A rhombus is the official shape. But if you say diamond, I think it's just fine, because you need to explain these things to little kids. So a lot of times they're familiar with the diamond shape. But a rhombus has parents with a parallelogram and kite. So it can have kind of like 2 definitions. So the first one is a parallelogram with four equal sides. Because parallelograms do not have 4 equal sides, so that we can put these marks on here. Okay. It's also considered a kite with 4 equal sides as well. because the kite, two sets of sides are the same consecutively, and the other two are also the same consecutively. But rhombuses are all 4 equal sides. Okay, so here's level number 4. Level 4 is a square, and the square has a lot of characteristics. Since it has 2 parents here, we have 2 branches coming down to the square, we can say that a square is a rectangle with 4 equal sides. Okay. And we can also say that a square is a kite. Oops. There's our 4 equal sides. It's a kite with 4 right angles. Okay. That's what squares can be. All right. So that's our hierarchy. We can ask questions like in number 1 here, is every parallelogram a kite? So let's take a look at parallelograms. Parallelograms are right here. Is every parallelogram a kite? Well, the parallelogram is not related to the kite because it's just on the same level, but it doesn't have a parent or child on the hierarchy as a kite. Okay, so parallelograms are not kites. So they're not related in the hierarchy. Is every rhombus a kite? Why or not? Now they are related, these two are related in the hierarchy, and they have a relationship right here. And every rhombus is a kite because rhombus are kites with this definition here. They are kites with 4 equal sides. Yes, because rhombuses are kites with 4 equal sides. Okay. All right, so now we're ready for 5 activities to discover some more properties about parallelograms and trapezoids for use with our teacher solutions. So I'm going to go ahead and go to the camera and cut out 5 parallelograms, and then we'll work on these 5 new properties. Okay, now we have our next section of our activity and the handouts. We have 5 activities. The first one is to, so since there are 5 activities, we're going to need 5 parallelograms, and we're going to need a few pieces of notebook paper to record our properties on that we're going to discover here with the parallelograms. And so if you don't have 5 parallelograms, go ahead and pause the video and cut out 5 parallelograms and get your notebook paper. Okay, now I'm assuming that you have your 5 parallelograms and that you've pressed play to resume the video. Activity number 1 says we're going to take a paper parallelogram, label the angles A, B, C, and D. So I'm just going to go ahead and start with the lower left as A, B, C, and D. Okay, so kind of going around clockwise. Okay, so our parallelogram has A, B, C, and D as our angles. And we're going to find and discover relationships between these angles. Okay. The next step is to go ahead and fold the parallelogram in half both ways. And so when we fold it in half like that, it doesn't work too well. So let's go ahead and fold it in half like this, like a hot dog first. It's a little bit easier to see. And then we're going to fold it in half again, like putting it like this way so that these match up here. Okay, and it asks you what you notice. So what do you guys notice about the angles in the parallelogram here? Maybe you can see it better with this way. There's angle A and angle C. And angle A and angle C actually end up going on top of each other, which means that they are equal. Notice that they are the same measure. They lay right on top of each other. Okay. And they're the same measure. So when we unfold it back and we take a look at what angle A and C are on our parallelogram, notice that the angle A is right here and the C is right here. Okay, so they're opposite each other along the diagonal, okay, of the parallelogram. All right, so they are equal there. When we also fold it, let's take a look at B and D. Okay, we fold it and compare them. We fold them the same way. So B and D are actually right in here. It's kind of hard to see. There's B and then there's D right here. They also lay right on top of each other. Okay. So in a parallelogram, the opposite angles are equal. A is equal to C or B is equal to D. Okay. So let's go ahead and record that discovery. On our notebook paper, we have a property. Okay, so these are like 2.4, section 2.4 on the quadrilaterals. Okay, here's the property. The opposite angles in a parallelogram are equal. The measures of the angles opposite each other in a parallelogram are equal. Okay. So we're going to go ahead and we can trace this right here. Trace this copy of the parallelogram. Label it like we did here with the label it as A, B, C, and D. Okay. And then I'm going to fold my parallelogram in this way, and I'm going to tape it here. You can see angle A and C better this way. Yeah, this way. You can see that by finding the folded copy and just kind of taping that down there. Okay, so we can tape it in into our notebook paper. You can see that they lie right on top of each other. Okay, because that's our property, we can go ahead and do our use. Okay, we're going to use the 3 steps like we did in the other chapter, or the other beginning of the chapter. So our use is we can say that the opposite angles are equal, and in this case, we can say that either A is equal to C or B is equal to D. We can set those, if we have, and we're given a parallelogram, we can set those angles equal to each other. And we can say it's because of the opposite angles of the parallelogram are equal. So the abbreviation that we will use is parentheses opposite OPP period, angle symbol with an S for angles, and then comma, 2 sticks meaning parallel, dash O-gram. Okay, so the book authors came up with the parallel sticks and O-gram thing, so I think they're pretty clever. Okay. So that's the opposite angles of a parallelogram. Alright, let's go to another property. With this property, we're going to take our second parallelogram and label it angles A, B, C, and D again. Okay. So once you have that, you can go ahead and take the paper parallelogram, label the angles, cut the parallelogram in half horizontally, and slide the top half down past the bottom half. Okay? So we're going to, before we do that, we're going to trace our parallelogram right here, so we can track to see how the directions are going with the angles, because it's saying to cut it. Okay. So this is our original parallelogram, A, B, C, and D. We're going to cut horizontally. So you're going to cut it right in the middle this way. So before, and it's okay if it's not exactly parallel. So before it was like this, and now the directions say to slide the top half down past the bottom half. So I'm going to take my parallelogram and to slide it down this way, and then tape it down so that the angles are next to each other. In my notebook paper. Okay. Let's go right about here. There. Okay. We want to place them right next to each other. So put tape here, and then put tape here, put tape here. So slide them right next to each other, and you notice. Take a look at what's going on. And draw my arrow again. What do we see about the relationships of the angles? Okay. Notice that angle A and angle B are right next to each other. Angle D and C are also right next to each other. And they match up really nicely so that their angle measures, so the angles are adjacent, and they actually measure along this line here. They match up with the line. Okay, so pass my arrow here. And D and C also match up on this line, okay, very nicely. So that means that these angles on the parallelogram are supplementary, okay, because they equal 180 degrees. So our property that we are discovering is that we're going to call these angles interior angles, okay, because they're inside. Okay. So A and B, for example, are right next to each other here, and they are supplementary. They're inside the parallelogram. So before I shifted, they're right here. So this is angle A. This is, and that's one side of the angle A, and that's the other side. Here's one side of B, and here's the other side of B. Okay, so those are the angles, and they are supplementary because when I shift them, they come right here, and they match up. Okay. So they're A and B. Notice that A and B are interior to these parallel sides right here. They're inside here, inside to these parallel sides. So we can call them interior angles. Angles, L-E-S. The interior angles of a parallelogram are supplementary. Which means that they equal 180 degrees. Okay, they sum to 180 degrees. So both A and C are, and B, D and so A and B are, and D, C and D are. So their use, notice that it's different than the first property, because the first property compares A and C, the opposite angles. This one compares the interior angles here. So A plus B is equal to 180 degrees. Or we can have C plus D is also equal to 180 degrees. Okay. So if we don't know one of them, let's say we have A and B are equal to 180, we don't know what B is, we can set a, whatever this is, like 30 degrees plus B equals 180. And we can find out what angle B is, the measure of angle B. So it's a pretty useful property called interior angles. Now the abbreviation for our teacher solutions is INT, angle symbol with an S. And in the book they want you to show what sides they're interior to. So A and B are going to be interior here, same as C and D. They're interior between these two sides that are parallel. Okay. So in order to label the sides, which sides are parallel, we're going to have to use some points. I'm going to draw the points in to my parallelogram and label them with capital letters. So this is going to be A, B, C, and D. Now they're interior to these two sides, okay? Sides BC and AD. Okay? So we're going to say that they're interior to these two parallel sides, BC being parallel to AD. Close it off. Okay? So that's our abbreviation. Okay? So our first page of properties has opposite angles are equal in a parallelogram. So A is equal to C, B is equal to D. The interior angles are supplementary. A and B add to 180 because they match up right here when we shift our figure. C and D add to 180 because they also match up along a line or segment, just a straight figure. And they are supplementary, they equal 180 degrees. So those are the interior angles. Moving on to our next parallelogram activity. Take our parallelogram and label the sides again, the angles again, A, B, C, D. Okay. And with this one, we're going to do kind of similar approaches to activity number 2. We're going to take our parallelogram, we're going to cut it in half vertically, anywhere on the vertical part. Okay. And then we're going to shift them again. So they were here together, and we're going to shift them here so to see how they match up with the other set of interior angles, interior horizontally, okay? So I'm going to trace my parallelogram, so let's use another copy here since I cut that one up. Trace my parallelogram here. So I know how my parallelogram was started. A, B, C, D. Okay, and I'm shifting it again. Okay, so I'm taking these and I'm going to shift them. Okay, this way. So I'm taking my right side and shifting it, my left side and shifting it past my right side. Since we're going to investigate what happens when they match up here. So I'm going to take some tape, tape it into my notebook. And so we have them fastened there. Okay. The property is going to be similar. Okay. It's a similar investigation, but it's the other way. It's not horizontal cut, but it's vertical cut. And notice that C and B were put together, and they also make a line here, along the segment there. D and A also are adjacent, and they form on the segment. So they're interior to the parallelogram this way. So this is the same property. Interior angles of a parallelogram are supplementary. Okay. So that means they sum to 180 degrees. The use on this one is slightly different from the others, so, but before we were able to compare A and B together like this, these interior to these ones, these two sides. But parallelograms are also parallel this way, and the interior angles to these two parallel sides are also supplementary. So we can see right here. Okay, so I'm going to go ahead and put my use. C plus B is right here. So C plus B, let's just do an alphabetical order. B plus C is equal to 180 degrees. Or A plus D is equal to 180 degrees. Both of those are supplementary. Go ahead and zoom in here. See that maybe a little bit better that way. The abbreviation is the same as the previous property, interior angles, INT, period, angle symbol with an S. But these sets of angles on this figure here are interior in a different way because they're interior to these two sides and not to these two sides. So these two sides I'm going to say are the parallel sides that they're interior to. So in order to do that, I'm going to label some points on my parallelogram. This will be the point A, B, C, and D. Now, since I'm parallel to this, these two sides are parallel, it's AB is parallel to CD. So I'm going to say AB is parallel to CD. And then I'm going to close that off. Okay? So that's, if you're going to compare these two angles here, you need to say that they are interior to these two sides. Okay. That was activity number 3. Activity number 4 has to do with trapezoids. And we're going to take our parallelogram and we're going to cut it into a trapezoid. So you can just cut off one of the sides anywhere and it'll make a trapezoid. Okay, so cut it off and now it's a trapezoid. Okay. So I have a trapezoid. I'm going to label the angles A, B, C, D again. So A, B, C, D. And I'm going to trace it here on my paper. So we know where we're starting in because we're going to do a similar investigation where we're going to cut it in half or into 2 parts. It's not exactly in half because it's a trapezoid. Label A, B, C, D. Okay. So I'm taking my trapezoid and we cut it horizontally like I did the first investigation with the parallelogram. And cut it horizontally like this. Okay. And I'm going to slide the top half down past the bottom half and compare. And upon investigation we can see that A and B match up very nicely. They make a line, straight segment. So that means that they are supplementary. And if you scoot this over again to match up C and D, you'll find that it is also supplementary. Okay? So when you cut it horizontally, the interior angles of a trapezoid are supplementary. I'm going to go ahead and tape it down like this with my first arrangement of A and B. Okay, so here's my trapezoid. A and B form a line. So the property is the same. The interior angles of a trapezoid are supplementary. Okay. The use is right here, A and B and C and D. So A plus B is equal to 180 degrees, or C plus D is equal to 180 degrees. Okay. The abbreviation is the same as with the parallelogram. INT, interior angles, angle symbol with an S. And we're going to say which sides are parallel. Now, the trapezoid only has one set of parallel sides. Okay, so I'm going to label the points so I can name my sides. A, B, C, D. Okay. And these two are, A and B are, and C and D are interior to these two sides. There's only one set. Okay. And that's going to be AD. Do the bottom one. Segment AD is parallel to segment BC. Okay. And close that off. All right. So we have, so it works for a trapezoid as well, but we're focusing on these two sets right here, these two angles here. This angle, angle B, is supplementary to this angle A. Or angle C, right here, is supplementary to angle D, right here. Okay. Now let's see if they can go, they're interior to these two segments. Let's see if they're interior to these two segments. So you can go crossways like that. So I'm going to take my next parallelogram and I'm going to cut it into a trapezoid again. Okay. I'm going to label the sides, the angles I mean, I'm going to label the angles, A, B, C, D. Okay. So labeled A, B, C, D. And I'm going to cut it, not horizontally like I did the first time, but vertically like I did with the second investigation. Second investigation with the parallelogram, or the third one, and see if they match up. So I've cut it like this. I'm going to slide them together and see if they match up. Now when C and B come together, do they make a straight line? No, they do not. When A and D come together, do they make a straight line? No, they do not. So therefore, we must conclude that the interior angles for a trapezoid only works with the ones on the left and right sides if you orient the parallel lines, segments, horizontally. If you do not, if you look at it with B and C, they do not match up. Okay? So this is the only way to view interior angles. For a trapezoid, just do the ones on this side and this side. Okay. All right, so that concludes our investigation with the parallelograms and the trapezoid. So a couple of new properties. Opposite angles are equal and interior angles are supplementary.